In this video, we will be talking about freefall in one dimension. In freefall in one dimension, we will be analyzing the motion of an object up or down, accelerating towards the center of the Earth constantly. This is what we will call acceleration due to gravity and label it with a lowercase g. For coordinate systems, we will typically label away from the Earth in the positive y direction and towards the Earth with negative y. The original kinematic equation xf equals x0 plus v0t plus 1/2 at squared can be changed to model freefall just by changing its variables to their vertical counterparts. We will change each x to a y. We will make the acceleration negative because it is towards the negative y direction, and we will replace a for g. The final equation will read yf equals y0 plus v0yt minus 1/2 gt squared. Yf will be defined as the final vertical position, y0 will be defined as the initial vertical position, and v0y the initial vertical velocity. G will represent our acceleration due to gravity. Lastly, t will represent time in seconds. In the second kinematic equation, Vf equals V0 plus At can be modified to Vfy equals V0y minus Gt. The cookbook is a list of steps that will help you solve these problems with ease. Step 1 is draw a sketch. Step 2 is set a coordinate axis. Step 3 is list the knowns and unknowns. Step 4 is pick an equation. And step 5 is solve for the variables you are being asked to find. Here's an example problem. Standing atop a 15-meter tall building is a man holding a ball out from his waist 1 meter high. When he drops the ball, how long does it take for it to hit the ground, and what is the velocity as it hits the ground? Using the cookbook, we will solve for the time it took to hit the ground. This starts with drawing a sketch, which we already did. Next is label coordinate axis. We will label positive y up and negative y down. Then we will list our variables. y0 will be 16 meters, yf will be 0 meters, v0y will be 0 meters per second, vfy we don't know, t we don't know, and g we know equals 9.8 meters per second squared. Then we will pick one of our equations to solve for t. For question A, we will use yf equals y0 plus v0y minus 1/2 gt squared because we are given initial and final vertical position as well as initial vertical velocity. For part B, we will use vfy equals v0y minus gt because we are solving for final vertical velocity. Step 5, solve each equation for the variable you are looking for. For A, our equation is yf equals y0 plus v0yt minus 1/2 gt squared. Plugging in the givens will give us 0 meters equals 16 meters plus 0 meters per second t minus 1/2 9.8 meters per second squared t squared. Now, solving the equation with algebra, we will yield the answer t equals 1.81 seconds. And for part B, we are using the equation vfy equals v0y minus gt. Then we plug in the givens, solve the algebra, and get negative 17.74 meters per second. Thank you for watching, and I hope this video helped you better understand freefall in one dimension.